The dependent variable does not differ at different levels of independent variable. In simple words, we can say that the variation of the dependent variable is so-called constant at different levels of independent variable. Estimation and assessment of the overall model. For estimation and assessment of overall model, there are certain types of methods, but two most widely used methods in SPSS are: number one, enter or direct method, and the second one is hierarchical method. Enter or direct method. This method shows the overall results of estimation and assessment of included variables at a time. Means SPSS will generate one single model and the results will be estimated through that model. On the other hand, the hierarchical method examines the contribution of each independent variable. This method generates number of models according to the number of variables. Well friends, that was all the theoretical overview of multiple regression analysis. Now I will show you how to perform regression analysis on SPSS. Here's the version 13 of SPSS. We'll go to File option, go to Open, Data. We will take a sample file in the SPSS folder, which is already present over there in your SPSS folder. Here's the file of employee data. We will open it. Go to variable view. Here you can see that there are 10 variables included in this data. Number one is ID or employee code. Second is gender. Third is date of birth. Fourth is education level. Fifth is job category or employment category. Sixth is salary or current salary. Seventh is salary beginning or beginning salary. Eighth is job time or months since the employee is hired. Ninth is previous experience of the employee. And 10th is minority classification. Now we will perform the regression analysis on this data file. Here we are interested in predicting the current salary of the employee on the basis of beginning salary, job time, that is months since he has been hired, and his previous experience. We will go to Analyze, Regression, Linear. Here you can see that there are two main boxes. The first one is dependent and the second is independence. We are interested in predicting on the current salary of an employee, so we will take current salary as dependent variable. We are going to predict this dependent variable on the basis of three independent variables, which is beginning salary, month since the employee has been hired, and the third one is his previous experience. We will go to statistics option. Here we will click collinearity diagnostics, continue. Then we will go into the option of plots, taking dependent on the y. and the last option, that is STRESID, and the X. Tick mark the histogram, tick mark the normal probability plot or MPP, and click continue. Now you can see that the method which we are using here is enter method. There are a number of methods available in SPSS. Stepwise method, remove, backward, forward. So here we are interested in enter method. We will click the OK button. And now SPSS will generate the results for us. Here SPSS has generated output. The first table is showing that the variables which are entered are previous experience, months since hired, and beginning salary. All these are independent variables. The method which is used is enter method, and the dependent variable is current salary. The second table is showing us the model summary. Here we can see a number of boxes over here. Now interpreting R. R is the multiple correlation coefficient. It shows the linear correlation between actual and estimated values of dependent variable. Its large value indicates a strong relationship between observed and estimated values of dependent variable. It will vary from 0 to 1. The value should be closer to 1. R square. R square is the coefficient of determination. It shows the adequacy of the model, that how accurate it is. Its value can vary from 0 to 1 also. The higher the value of R square, the better is the prediction. Adjusted R square. This is the main value for our analysis, which will be incorporated in our research. Well, adjusted R square, it is the modified measure of R square. Although the addition of independent variable will increase the value of R square, but adjusted R square may fall if independent variable has little explanatory power. Here we can see that the value of adjusted R square is 0.803 or 80.3%. We can say that our independent variables accounts for 80.3% variability of our dependent variable.